Alright, so let's look at this example. This here is an example that fits the conservation of energy section that we're talking about. I have a skier at the top of the hill and a skier part way down the hill, and then part B, the skier's at the bottom of the hill. And the question is, if there's no friction, so the no friction part, there's no engines or anything, this indicates to me that there's no work. So work equals 0. I like to put work equals 0 right on here. And it says we want to know the velocity here. So I've already gone ahead and labeled these, but I'm going to put an I for initial and an F for final. So they're going to match my formula when I do it in a second. And I want to label them with the type of energy. And I do this so that I can keep everything kind of sorted out. So there's just EG here. And at this point I have EG because I have height. And I also have EK. So when I use my formula, and I'm used to this form, this one, there's two variations. But this one is the one I like because it seems to have less issues with people trying to decide. Just use the one formula, sort it out. So we said there's no work. So this is conservation mechanical energy. And mechanical energy, I'm going to write this here because I haven't done the best job explaining it. Mechanical energies are EK, EG, and EE. So it says the conservation of mechanical energy says all of the energy that exists between these three types of energies that exists at point 1 equals all the energies, the three types that are existing at point 2. So if I look at this, EI is this spot right here. So I'm going to change EI for EG. So at the beginning we have all gravitational. At the end we have gravitational and kinetic. I'll put the little apostrophe there to signify after. So EG prime. And then I'm going to change it. You could do them all off to the side, but it gets kind of ugly then because there's stuff going on everywhere. So EG is mass times gravity times height. And again, it's mass times gravity times height. Plus 1/2 mv squared. Now at this point we could put all our numbers in, but I'm going to go one step further and I'm going to look, and I notice that all three terms, so the EG, and the EK, all have a mass in them. So I'm going to eliminate the mass. And now I'll put my numbers in. So 9.8. And I like to separate this so I know my initial point is up here. So I've put on the information and the type of energy so that I know the 4 goes with the missing velocity, not the 10. So I've got my 10 right here. And this equals 9.8. Remember, we've canceled the mass out. So the height is 4 plus 1/2 times the velocity squared. So I've gone ahead and put my numbers in. I multiplied them out, did the math. I'm at this point right here. Take square root of both sides. And I should get an answer of plus or minus 10.84 meters per second. So the velocity at this point is 10.84 meters per second. We could have done this without canceling the mass out. You're still going to get the same answer. So just to review, label your diagram, and I want you to label them with the types of energies, and then it's easier to figure out what goes on which side of the equal sign. So the beginning point goes on the left side. Any work that's there goes with it. And on the right side is anything that's at point 2. When you do part B, it's going to be the same thing, but I'm going to be down at the bottom, and all I have at the bottom is EK. So if I go through this, then I won't have lost the 39.2 in my equation. So this number is going to be bigger, right? It's going to be 98 multiplied by the 2, and I should get an answer of 14, and I'll just show you that quickly. I believe I have it here. So the same thing, it's EG at the top. There's no work. It's EK at the bottom, so I've labeled it with I and F also. So all of the mechanical energy is conserved. So EG was my mechanical energy at the top, EK at the bottom. I've crunched my numbers, and I get 14 meters per second. I hope that makes sense. I've got another couple of videos for you, and I'll have those up shortly.